Okay, for our second example today, we have a problem that's very similar to the first one, but there's a few things in the setup of this one that's a little bit different, so we'll go through the second problem here as well. In this scenario, we have a dock that's 4 meters above the water, and there's a boat that's being pulled in by a rope and is approaching that dock at 1 meter per second. If the boat's initially 8 meters from the dock, how fast is the length of rope changing at 5 seconds? So again, I'm going to draw just a little diagram so we can picture what's happening here. Okay, so there's, we'll say, the post for our dock, and we have some water here. And then someplace out here we have our boat attached by a rope, and someone up on the dock is actually pulling that boat in. So as this boat is being pulled in, again, we're thinking what is constant and what is changing. Okay, so the height of the dock, this side here, that will stay constant at 4 meters. However, the distance from the boat to the dock, that will be changing, as well as the rope that's being pulled in to move the boat closer will also be changing. So both of those we'll call variables. The given in this problem then is they're telling us that the boat is being pulled in so that it is approaching the dock at 1 meter per second. So we know here then that dx by dt, the distance from the boat to the dock, is getting smaller, so negative 1 meter per second. Required then in this problem, we are trying to figure out at what rate or how fast is the length of rope changing, so this distance here, so we are trying to figure out then dy by dt, and this time we want that at 5 seconds, so there's our when. We want this to happen when 5 seconds has passed. Our solution then, similar to our last one, starts out in the same way. We have a right triangle, so we can use Pythagorean theorem here. So in this one, we have that x squared plus 4 squared is equal to y squared. We're going to differentiate with respect to time. In your solution, you can either write explicitly that line out so that people can see you're doing that, or we can go ahead and just start to do the differentiation with respect to time. So if I do that in this example, then I would have the derivative of that first term is 2x multiplied by the derivative of x with respect to t, plus the derivative of a constant, which is 0, and then the derivative of y squared, so 2y multiplied by the derivative of y with respect to t. If we're now going to try and solve for dy by dt, that means I should have values for all the other variables in the question. Okay, we do know that dx by dt is -1, but at this point we do not have values for x or for y. What we do know though is that this whole scenario is taking place. We want to hit pause on this boat moving in, kind of like a movie. If we think of this boat sliding in, we want to hit pause at 5 seconds and take a look at what are those measurements at that time. So again, as an aside here, I'm going to say what is happening at 5 seconds. So if we picture this boat sliding in, and then we hit pause at 5 seconds, what would that triangle look like? So we do know that the dock would still be 4 meters high, but now we need to figure out what would the value of these variables be at 5 seconds. So we go back to the problem and we say, well, initially this length here was 8 meters, but it is decreasing at 1 meter for every second. So if we're hitting pause at 5 seconds, then we can say it's decreasing by 1 meter for every 5 seconds. In other words, that distance would then be 3 meters. If we want to figure out the last side here, I'll still call this y. We now know two sides of the right triangle, so we could use Pythagorean theorem. Y squared equals 4 squared plus 3 squared, or y is 5. So at 5 seconds, we've now managed to figure out that the value of x is 3 and that the value of y is 5. So we can come back to our equation. We can say then we have 2 times 3 times -1 must equal 2. And in place of y, we can put in the 5. dy by dt. A little bit of simplifying, -6 equals 10 dy by dt, or dy by dt is -3/5. Therefore, the rope length is decreasing at 3/5 meters per second at 5 seconds. Hope that helps. Okay, the assigned questions will be posted in the assignment. Okay, if you have any questions, please feel free to email me and ask away. Have a good day, guys. Bye.